Okay, before you get started on this exponential growth and decay worksheet, I want to do a couple for you to make sure you're on the right track. And you're going to want to reference the video you did the other day where we were reminded that exponential growth is going to look like this, where P is your initial population and R is your percent of growth and T is your time in years. Okay, so when you first look at an equation like this, you should notice that it's exponential because the input variable t is in the exponent. And in this form, we notice that our p-value is in the same position as our a value, which is the same position as our y-intercept. Okay, so what is our initial value? Our initial value here is going to be 1200. Then it says, what is the rate of growth or decay? So when you look over here, when you see this plus sign, and knowing that when we add 1 plus 0.3, we are going to get 1.3. And since this whole thing is greater than 1, we know it's growth. And the rate of growth is this number turned into a percent. So 0.3, when we turn it into a percent, we move the decimal 2 places to the right, and it's 30% growth. So this represents exponential growth. The next problem, when we are subtracting from 1, that's going to be decay. So the decay formula looks like this. So this one's exponential decay. The initial value is going to be this first start value of 55. And the rate of decay, we're going to do just like we did before. We're going to look at this R value, so 0.02, and we are turning that into a percent. It's 2% decay. Okay, now here's where I want to stop and talk to you for a minute, because if we use our calculators to actually figure out what 1 minus 2% is, you'll see that it comes out to be 0.98. So this formula can be, this expression can be rewritten, or this equation, as 55 times 0.98 to the t power. And it's your job to be able to recognize exponential decay if it's written as 1 minus r, or if they actually simplify this and get 0.98. So the way you can recognize that is whenever this entire number is less than 1, it's going to represent decay. Okay. Now, if you think about this for a minute, we've got 2% decaying. So if you can imagine, if this is your entire population, if 2% is decaying, it makes sense that 98% is the percent that remains. So once you subtract this, you get 98%, meaning that's the population that occurs and keeps happening year after year. Okay? So through the rest of this problem, or this worksheet, notice that they already have these values already simplified. So this one already is added together. The 1 plus the R value is added together to get 1.25. Okay, so you will answer through these questions. Now down here, when you get to something less than 1, it's going to be your job to think about, okay, if 65% remains, what's the percent that was leaving? In other words, what do we have to subtract from 1 to be left with 65%? And that's 35%. So it's going to be your job to make that connection between here and here, to figure out the growth, the decay rate. So in this problem, our rate of decay is 35%. because that's the amount that's being taken away. The 65% is the amount that remains year after year. Okay? Then if you turn this over, I'm going to do one of these problems. So let's go to number 11. Your starting salary at a new company is $34,000 and it increases by 2.5% each year. So we're going to write an exponential growth function. So f of x equals, so we start with our starting amount, and because it's growth, we're going to do 1 plus, and we turn this 2.5% into a decimal. And we do that by moving the decimal 2 places to the left, and it's to the x power. Now, most mathematicians will do this all in one step and write it as 1.025 to the x power. Then what will your salary be in 5 years? You go here, 34,000 times 1.025 to the 5th power. Okay, so 2.5% raise after 5 years. You went from $34,000 to $38,467. This is money. It says round to the nearest cent. So the nearest cent is where the 7 is. So you look to the right of it. That 9 is going to make it bump up to 88 cents. Okay. All right. Please complete this worksheet, front and back. And then you are going to turn it in and hand it into the sub. Thank you.